Imagine a world draped in sheets of ice where temperatures plummet and landscapes transform into frozen wastelands. This is not a scene from a science fiction film, but a glimpse into Earth's history, the Ice Age. An ice age is a period of long-term reduction in Earth's temperature, resulting in the expansion of polar ice caps and glaciers. These icy epochs have occurred multiple times throughout our planet's 4.5 billion-year history, each leaving an indelible mark on Earth's climate, geology, and life itself. Ice ages have a profound impact on Earth's climate, causing significant shifts in temperature and precipitation patterns. During these frigid periods, global temperatures drop, and vast areas of land become encased in ice. The growth of ice sheets reflects sunlight back into space, further reducing Earth's temperature. This phenomenon, known as albedo, amplifies the cooling effect and contributes to the severity of ice ages. The presence of massive ice sheets also disrupts atmospheric circulation patterns, leading to changes in precipitation. Some regions experience increased rainfall, while others become drier. These climatic shifts have far-reaching consequences for ecosystems and the distribution of plant and animal life. The relentless advance and retreat of glaciers during ice ages have dramatically sculpted Earth's surface, carving out valleys, grinding down mountains, and depositing vast quantities of sediment. As glaciers flow, they erode the underlying bedrock, picking up rocks, soil, and other debris. This material, known as glacial till, is transported by the glacier and deposited elsewhere when the ice melts. The weight of ice sheets, often miles thick, depresses the Earth's crust, causing land masses to sink. When the ice melts, the land slowly rebounds over thousands of years, a process known as isostatic adjustment. This rebound effect can alter drainage patterns, create new lakes, and even influence the frequency of earthquakes. The exact causes of ice ages are complex and still debated by scientists. However, several factors are believed to play a significant role, primarily related to Earth's orbit and the amount of solar radiation received. Variations in Earth's orbit around the Sun, known as Milankovitch cycles, influence the distribution of solar energy received on Earth's surface. These cycles operate over tens of thousands to hundreds of thousands of years and can trigger changes in Earth's climate. Other factors include volcanic eruptions, which release massive amounts of ash and aerosols into the atmosphere, blocking sunlight and leading to cooling. Additionally, changes in ocean currents and the composition of the atmosphere, particularly greenhouse gas concentrations, can also influence the onset and duration of ice ages. Section 5. Life in the freezer. How animals and plants survived. The onset of an ice age presents significant challenges to life on Earth. As temperatures plummet and ice sheets advance, ecosystems are dramatically altered. The landscape becomes a frozen wilderness, and survival becomes a daily struggle for all living organisms. Animals and plants must adapt to colder temperatures, reduced food availability, and altered habitats. The cold forces them to develop new strategies for finding food, staying warm, and protecting themselves from the elements. Many species migrate towards the equator in search of warmer climates and food sources. This migration is often a perilous journey, fraught with dangers and uncertainties. Birds, for instance, fly thousands of miles to reach their wintering grounds, while herds of mammals travel vast distances to find sustenance. Others evolve specialized adaptations to survive the harsh conditions. These adaptations can be physical, such as thicker fur or fat layers, or behavioral, like hibernation or changes in feeding habits. Some animals, like the woolly mammoth, developed thick fur and layers of fat for insulation. These physical changes allowed them to retain body heat and survive in the freezing temperatures. Others, like the reindeer, evolved specialized hooves for digging through snow to find food. These hooves are not only useful for foraging but also provide stability on the icy ground, preventing slips and falls. Plant life also undergoes transformations, with many species dying out and others, like conifers, thriving in the colder, drier conditions. These hardy plants have adapted to conserve water and withstand the cold, ensuring their survival through the harshest winters. The ability to adapt and evolve determines which species survive and which succumb to the challenges of the Ice Age. It is a testament to the resilience and ingenuity of life on Earth, constantly evolving to meet the demands of an ever-changing environment. Section 6. Giants of the Frost. Remarkable creatures of the Ice Age. The Ice Age was home to a fascinating array of creatures, many of which are now extinct. These animals thrived in the harsh, cold environments, adapting in remarkable ways to survive the freezing temperatures and scarce food supplies. These animals, known as Megafauna, were giants compared to their modern-day counterparts. Their large size was an adaptation to the cold, helping them retain heat and fend off predators. The iconic woolly mammoth, with its shaggy coat and enormous tusks, roamed the frozen landscapes alongside other remarkable creatures. These mammoths were social animals, often traveling in herds to protect themselves from predators and to find food. The woolly rhinoceros, a massive herbivore with a thick woolly coat, grazed on the tundra vegetation. Its large size and thick fur helped it survive the cold, while its horn was used to dig through snow to find food. Saber-toothed cats, with their fearsome elongated canines, stalked the icy plains, preying on large herbivores. These predators were built for power, with strong limbs and sharp claws to take down their prey. Giant sloths, towering over 10 feet tall, used their powerful claws to strip leaves from trees. Despite their size, they were gentle giants, feeding primarily on vegetation and using their size to reach high branches. These remarkable creatures are a testament to the resilience and adaptability of life, even in the face of extreme environmental challenges. Their ability to thrive in such a harsh climate is a reminder of the incredible diversity and ingenuity of nature. Section 7. The End of an Epoch. What happened to the megafauna? As the Ice Age drew to a close and temperatures began to rise, the megafauna that had thrived in the colder climates faced a new challenge, adapting to a rapidly changing world. While the exact causes of their extinction are still debated, several factors likely contributed to their demise. Climate change played a significant role, as rising temperatures altered habitats and disrupted food chains. The spread of forests into former grasslands reduced grazing lands for herbivores, impacting the entire ecosystem. Additionally, the arrival of humans with their hunting skills and ability to alter the environment likely hastened the decline of these magnificent creatures. Section 8. Echoes of the Past. Evidence of past ice ages. Evidence of past ice ages is etched into the very fabric of our planet, from glacial valleys and moraines to fossilized remains of extinct creatures. Geologists study these features to piece together the history of Earth's glacial periods. Ice cores, extracted from glaciers and ice sheets, provide a valuable record of past climate conditions. These cores trap bubbles of ancient air, allowing scientists to analyze the composition of the atmosphere at different points in time. Fossil remains of plants and animals provide further clues about the types of life that existed during ice ages and how they adapted to the changing environment. Section 9. Frozen in Time. Fascinating facts about ice ages. During the last ice age, which peaked around 20,000 years ago, ice sheets covered approximately 30% of Earth's land surface. These massive ice sheets were so thick and expansive that they dramatically reshaped the planet's geography. Valleys were carved out, mountains were ground down, and entire ecosystems were transformed. The sheer scale of these ice sheets is hard to imagine today, but their legacy is still visible in the landscapes they left behind. The weight of the ice sheets during the last ice age was so immense that it caused sea levels to drop by approximately 400 feet. This drop in sea levels exposed vast areas of land that are now submerged. Coastal regions extended far beyond their current boundaries, creating new habitats for plants and animals. The pressure exerted by the ice also caused the Earth's crust to deform, a process known as isostatic depression. When the ice melted, the land slowly began to rebound, a process that continues to this day in some regions. The Bering Land Bridge, a strip of land that once connected Asia and North America, was exposed during the last ice age, allowing humans to migrate from Asia to the Americas. This migration had a profound impact on the development of human societies. As people moved into new territories, they adapted to different environments, leading to diverse cultures and ways of life. The Bering Land Bridge is a key piece of the puzzle in understanding human history and migration patterns. Some scientists believe we are currently in a warm interglacial period, meaning another ice age could occur in the future, albeit thousands of years from now. The Earth's climate has always been dynamic, with periods of warming and cooling. Understanding these cycles helps scientists predict future climate changes and their potential impacts. While the idea of another ice age might seem distant, the study of past ice ages provides valuable insights into how our planet's climate system works. The study of ice ages and their impact on Earth's climate and life is crucial for understanding past environmental changes and predicting future climate scenarios. Glaciologists and climate scientists work tirelessly to uncover the secrets of these frozen periods. By analyzing ice cores, sediment layers, and other geological evidence, they piece together the history of Earth's climate. This research not only helps us understand the past, but also prepares us for future changes, ensuring we can adapt and mitigate the effects of climate change.